Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code P1172 indicates that the Air-Fuel AF Sensor 1 circuit is out of range high. This code pertains to the Honda Accord models from 2012 to 2017 and signifies a potential issue with the vehicle's fuel management system. The AF sensor, also known as an oxygen sensor, plays a crucial role in regulating the air-fuel mixture entering the engine, thus ensuring optimal performance and emissions control. When the circuit is reported to be out of range, it can lead to improper combustion, reduced fuel efficiency, and increased emissions. The location of sensor 1 is typically in the exhaust manifold, upstream of the catalytic converter, which allows it to measure the exhaust gases exiting the engine directly. Proper functioning of this sensor is vital for accurate readings sent to the Powertrain Control Module, PCM, which adjusts fuel injection accordingly. While troubleshooting DTC P1172, it is important to consider preventive maintenance strategies to avoid future occurrences of this issue. Regular inspections of the AF sensor and its wiring connections play a crucial role in ensuring the system remains fault-free. Any signs of wear, corrosion, or poor connections should be addressed immediately to promote optimal performance. Additionally, keeping the connections clean and secure prevents any electrical disruptions that could affect sensor readings negatively. Monitoring the quality of fuel is another preventative tactic. Using low-quality fuel can result in contaminants that may degrade sensor performance over time. Adopting these maintenance habits can significantly enhance the vehicle's longevity while also improving overall engine performance. In conclusion, DTC P1172 denotes significant issues with the AF sensor circuit in the Honda Accord from 2012 to 2017. Adhering to a structured troubleshooting protocol, which includes diagnostics, sensor checks, and PCM adjustments, is essential throughout the repair process. Each step not only clarifies the current state of the AF sensor, but also allows for accurate resolution of the DTC. Additionally, implementing preventive maintenance measures will serve to bolster the system against future errors, enhancing reliability and performance. Understanding this process and keeping up with routine assessments will not only save on repair costs, but also optimize the driving experience. By actively engaging with these strategies, vehicle owners can ensure their Honda Accord remains roadworthy and efficient for many years. DTC P1172 indicates a malfunction in the AF Sensor 1 circuit, which is responsible for monitoring the oxygen levels in the exhaust gases. It directly affects the air-fuel ratio that the engine relies on for optimal operation. An accurate reading from this sensor is crucial, as it influences the decisions made by the Powertrain Control Module, PCM, regarding fuel delivery and timing adjustments. The AF sensor is strategically located before the catalytic converter, which allows it to effectively measure the composition of exhaust gases before they undergo further treatment. Should the sensor fail or report values outside acceptable ranges, the engine may operate inefficiently, leading to poor fuel economy and elevated emissions levels. It's essential to ensure that the connections and wiring to the sensor are intact to prevent erroneous readings and system failures. Several potential causes can lead to the P1172 trouble code being triggered. One primary issue could be a faulty A-feed sensor itself, which may send incorrect information to the PCM. Wiring issues may also play a significant role. Damaged or corroded wires can interrupt the signal between the sensor and the ECU, leading to erroneous readings. Furthermore, poor connections at the A-feed sensor or the PCM can cause erratic signals and may result in the DTC being set. It's important to inspect the connections visually and ensure there are no signs of wear or damage. Additionally, environmental factors such as extreme temperatures and exposure to contaminants may affect the functionality of the sensor, making it necessary to assess all conditions before concluding on repairs. The presence of DTC P1172 can lead to multiple symptoms that indicate a malfunction in the air-fuel mixture management. One notable symptom is an increased fuel consumption, which can occur because the engine might be running too rich or too lean due to inaccurate sensor readings. In addition to fuel inefficiency, drivers may experience various performance issues, including rough idling, hesitation during acceleration, or even stalling, as the engine struggles to achieve a proper air-fuel ratio. Furthermore, the DTC can lead to potential emissions failures during inspections due to the compromised functioning of the emissions control systems. If these symptoms arise, they warrant immediate attention to avoid further damage to engine components and address any potential legal implications related to emissions regulations. In the first troubleshooting step for DTC P1172, ensure that the ignition switch is turned to on mode, either by turning the key or pressing the engine start-stop button. This action powers up the vehicle's electronic systems without starting the engine to allow for data retrieval. Next, utilize the Honda Diagnostic System HDS to clear the detected DTC. Clearing the code is essential to obtain a true representation of the current state of the sensor and associated circuits. After the code is cleared, start the engine and hold the engine speed at 3,000 revolutions per minute, RPM, without any load. Maintaining this RPM simulates operating conditions that can trigger the radiator fan, allowing for effective data monitoring. At this point, it is crucial to observe the onboard diagnostics (OBD) status for the P1172 DTC using the HDS to inform further actions. Upon monitoring the OBD status with the HDS, if the system indicates a failed status concerning DTC P1172, the next step is to replace the AF sensor, Sensor 1. A failed result confirms that the sensor is malfunctioning and likely not providing accurate readings to the PCM. Replacing the faulty sensor is vital to restoring proper engine function and ensuring efficient fuel management. After the sensor replacement, it is essential to conduct a repair verification process to ensure that the issue has been adequately resolved. If the HDS indicates passed, the system is operational, indicating that the problem has been rectified. Keeping track of these procedural steps is key in effective troubleshooting and ensuring the vehicle returns to optimal performance levels. If the HDS shows a passed indication after the initial steps, it suggests that the AF sensor is operational at that moment. However, if it indicates an intermittent failure, it may suggest that the issue can come and go, and further investigation is warranted. In such scenarios, check for poor connections or loose terminals at the AF sensor and the PCM. Visual and physical inspections can reveal problems not immediately apparent, including corrosion, dirt, or fraying wiring. Addressing these issues may resolve the DTC. Driving the vehicle can also help in identifying conditions that trigger the DTC. Thus, it's critical to document any erratic behavior or warning lights. This method also allows for real-time monitoring of the OBD status until a more stable result is achieved. Finally, if the HDS indicates out of condition for DTC P1172, it suggests that the specified test conditions have not been met. At this point, it is necessary to re-establish the test conditions detailed in previous steps to perform a thorough verification. This includes ensuring the engine is warmed up and verifying all connections and signals as outlined earlier. If the OBD status continues to indicate an issue, returning to Step 1 is often the best approach for comprehensive troubleshooting. Consistent engagement with the complete process will facilitate an accurate diagnosis and can prevent overlooking critical factors that may contribute to the persistent issue. At this juncture, it's recommended to cycle through the diagnostic tests again to confirm any outstanding issues and proceed accordingly. After completing repairs for DTC P1172, it is crucial to conduct a final repair verification. This ensures that the A/factor sensor and any associated components are functioning correctly. Start by turning the ignition switch to on mode, similar to the initial troubleshooting steps. Use the HDS to reset the powertrain control module, PCM, which refreshes its memory and removes any potential error codes generated during the previous malfunction. Performing the PCM idle learn procedure is the next step. This allows the PCM to adapt to changes and establish correct idle states. Ensuring that the engine is held at approximately 3,000 RPM allows the system to recalibrate fully. Following these procedures guarantees that all systems are back to normal, significantly reducing the likelihood of the DTC resurfacing. Please like and subscribe to the channel. See you next time.